Hello, I'm Dan DeBacker. I lead the service provider, product management, and engineering team here at Extreme. And in today's session, we'll talk about internet peering and border routing solutions. So let's get started. Extreme Routing has a long heritage. Now, this has been through acquisition, starting back in the days of Foundry, then into Brocade, and now into Extreme. So we have taken the technologies for border routing and internet peering and have really matured them and grown them over the past several years. So let's look at some of the different value propositions that we have to offer. First and foremost, it's all about performance. So our ability to provide ultra deep buffers give you the maximum performance. And we'll go into more details of exactly what that means and why it's important. Secondarily, it's all about internet routing scale. The route tables continue to expand at a very rapid pace. And so having the ability to future-proof as best you can with additional route scale capabilities inside the boxes, absolutely paramount for solutions that need to work not only today, but into the future. Then we look at security. There's all different types of mitigations that are possible, all different types of attacks that are happening on a constant basis. So we'll talk about the different security solutions that we have that are really inherent and built into our border routing, internet peering opportunities. Then we'll talk about network visibility. Now, this is an interesting concept. We have an opportunity to really take the tools and move them out closer to where the traffic flows. And we do this through something called integrated application hosting, where we have a guest VM that resides directly on the router. So we can look at traffic directly right on that router without having to try to bring that traffic back to a set of centralized tools. So it really makes efficiencies in troubleshooting, in visibility to see what's going on directly on that box. And then lastly, with some of our solutions, we have some good flexibility, what we call pay-as-you-grow. So it's a ports on demand or a capacity on demand solution where you can buy a piece of hardware and only enable a smaller subset of ports to reduce your initial cost. And then over time as needed through licensing, just apply a license and turn on more capacity, more ports on those solutions. So we know it's not a one size fits all world, and we try to make as much flexibility and make it fit and tailor the business needs as best we can. So let's move on. If we look at the SLX platforms, we'll start first with the SLX 9540. So this is a 48 port, 1/10 gig SFP plus platform. We have 6 ports of 100 gig QSFP 28 on that box. So as you can see there also 6 gig of ultra deep buffers on the box with the ability to support 1.5 million V4 routes and up to 140,000 IPv6 routes. If we move up a bit, we go into the SLX 9640. So different form factor. You can see here 24 ports of 1/10 gig SFP plus, and then 12 ports of 100 gig. Again, 6 gig of tunable buffers, but the route scale here substantially increased. So one of the big differences between the 9540 and 9640 outside of the port configurations is the route scale. 9640 has a much higher route scale because we employ an external TCAM to provide that added capability for more routes. The 9640 also provides us the capability to have multiple routing tables across multiple VRFs. So in the situation where I want to have multiple tables, I want to have different VRFs, maybe different classes of service for customers, perfect solution because we can put those route tables in different VRFs and then apply different policies for traffic forwarding. And then lastly, the newest addition to the portfolio, not really all that new, it's probably about a year it's been here, is the SLX 9740. So the SLX 9740 comes in 2 different variants, a 40 port by 100 gig and an 80 port by 100 gig. Now here again, you can see, pretty good route scale, 3.5 million IPv4 and 3.5 million IPv6 route scale. Much higher capabilities from a buffering perspective, and really that just comes from the port count. Going to 40 ports of 100 gig, we now have 8 gig of tunable buffers. Forwarding performance obviously much different also here. So a lot of different opportunities for routing capabilities in different platforms. And again, not without having to try to force fit a single platform into every type of a solution, but yet at the same time, providing the performance, providing the scalability. The other nice thing here is that all of these platforms support the same operating system, SLX OS. So from a feature standpoint and things of that nature, the way you configure the boxes, they all look identical from that point of view. So we don't really require different versions of code on different types of routers and things of that nature. So everything there built in, all the same OS across all of them, same interface, same way to make the configurations across the routing platforms. So if we take a quick snapshot and look at the different use cases, we can start from the bottom where end customers have border routers that then tie into their internal networks. In most cases, those will be connected into the ISPs, and the ISPs connected into the IXPs. Fortunately for us here at Extreme, we have solutions that fit across all of these different scenarios. And because no two networks are the same, it's really nice to have a combination of those different types of platforms with different speeds and feeds, different port configurations to really best fit the scenarios that go across all of these different use cases. So from that standpoint, we look at how do we fit this in? Well, it's not really saying that we have to use a specific box in a specific area of the network. It really depends on the requirements in the use case, and then we can best fit that box into that solution. All right, let's go talk about some of these cool value propositions. So the first piece is around high performance. So a lot of times we know that deep buffers are needed, but what exactly do the buffers do for us? Or why exactly do we need those buffers? As you can see on the right-hand side, I've got a couple of different examples. At the top, it's all about speed mismatches. So in this day and age, when things are really, run the gamut from 1 gig to 10 gig, 25, 40, 100, 400. I mean, there's a lot of different speeds and feeds available. Now, as things are connected differently, as you can see here, the data center, the campus, the internet, DMZs, they can all be connected at various speeds. Now, when we go from very high to very low, we need the ability to buffer that traffic. So we don't want to drop the traffic, and we don't want to, go back into the days of sending pause frames and trying to slow everything down. I think we've all experienced issues in the past. And so buffering is really our best option here to maintain traffic flows, maintain service without dropping traffic, without slowing networks down. So the speed mismatches really play a big deal into why we need the buffering. And then the one on the bottom, long flows, short flows, bursty traffic. Especially in these scenarios where we talk about border routing and internet peering, the packet sizes are obviously not going to be very consistent. So a bunch of small little packets, long packets. So, basically, when traffic gets stuck, when a bunch of small traffic gets stuck behind some very large packet sizes, that's where, again, buffering comes into play. So really buffering is kind of the solution that helps smooth everything out to maintain the performance across the network. And so that's why, for us, from a routing perspective, it's really, really key that we stick with the deep buffer platforms. It's not to say that a shallow buffer switch could not do routing. It absolutely can, but it doesn't have that capability to absorb the speed mismatches and this type of bursty traffic. So at a point in time, you will definitely see performance implications if you try to use a shallow buffer platform, really where a deep buffer platform is much more appropriate. So now we'll look at security. Everyone is very keen on security. as I said, there's all different types of attacks that happen, DDoS attacks, external attacks, all of those types of things. So we offer multiple layers of protection. The first thing we talk about is BGP flow spec. So the graphic there at the top right shows you just a real high level picture of our ability to support flow spec. This is obviously a multifaceted solution. We work in conjunction with DDoS analyzers to really complete that entire solution. The second piece and the second bullet here is around BGP RPKI. So really, again, a solution where signing of records to make sure that the routes are valid becomes very, very important. So we don't have any type of attacks from that perspective. And then the other two bullets there, as you can see, high scale prefix filters, and then just the basic systems protection around receive ACLs, ASIC ACLs, rate limiters for data plane. So there are a lot of different tools that are really built into this solution to really harden the border routing and those peering solutions. It's very important. We also provide some technical configuration guides and best practices for deploying routers. But once we get into more of the system protection and the different types of filtering and things of that nature, it does really become customized to the environment. And the beauty of this is that you can customize it. So we can give you some basic blueprints and some guidelines on how to get this going. But there's always going to be modifications and tweaks to better harden the solution for your specific environment. Network visibility. So earlier I mentioned about integrated application hosting. It's a pretty long marketing name. And it's really a fancy name for the fact that we have a guest VM that runs inside of the SLX platform. So it runs in a KVM environment. As you can see from the picture here, we have a dedicated 10 gig path from the switch itself into this guest VM. So this guest VM is really not meant to run NFV type applications. I don't want to run a full-fledged firewall or a load balancer or things of that nature because the data path is 10 gig. But really what this is meant for is the ability to load analytics tools directly into that guest VM. So if I'm having a problem on a router, the first thing I want to do maybe is look at a packet capture. Let's just take a quick look, see what's going on, see if I can just, from a very high level triage the situation. Well, in a lot of cases where you don't have this capability of having a VM inside the box, that means that you have to either take an analyzer, physically attach it to the router, or you have to do some type of RSPAN, ERSPAN, tunnel traffic back to an analyzer. It's not always quick, it's not easy. It takes additional configuration and infrastructure. So let's eliminate all of that. Let's just take our analyzer, be it TCP dump or any of these other types of tools, and let's put it directly on the VM. And then let's take traffic that's coming in or out of that router and direct it into that guest VM, directly into that analyzer tool where I can take a look at it immediately on box. So instead of centralizing all my tools and trying to bring my problem to my tools, I'm going to take my tools and I'm going to decentralize them so that I can look at all of those areas as close to the situation as I possibly can. So this is really all about becoming much more efficient, reducing the mean time to innocence to see where is that problem happening on the network, and having the tools accessible when I need them, where I need them, directly on the box. So a lot of flexibility here with the guest VM from an analytics perspective. Another good example of a tool that we can throw out there is perf sonar. So I want to understand the performance of my network. So we can take perf sonar, put it on the guest VM, and actually have perf sonar run through the production network to other routers and give us some really good analysis of the performance and what's going on. So there's a lot of different things that we can do with this concept of the guest VM that sits inside of this. Now, the first thing you might be thinking is, well, could this compromise my router? So if something goes sideways in the guest VM, am I going to brick my router? Is it going to cause problems? Absolutely not. The guest VM is 100% garden walled off from the router itself and from the OS itself. So we dedicate a number of cores, we dedicate memory, we dedicate disk space just for the guest VM. So it runs 100% isolated from that perspective. So no matter what happens with the VM, the switch itself, the router itself will continue to run and work as intended. So it's a very safe solution and very powerful, because now I've taken a bunch of tools, I put them directly on this box, and I can see things much, much faster, quickly, look at resolving issues, or like I said, with Personar, quickly do some testing from a performance standpoint. So, really the sky's the limit on what we want to do here. I think the only thing I want to make sure I caution everyone on is, again, it's a 10 gig data path. So let's not try to do too much. Again, it's intended more from an analytics tools type perspective. So as long as we adhere to that, I think it's a great opportunity to provide a really differentiated value from a routing perspective and an overall routing solution. So it's really, it's not always about, the performance and the scalability, but it's also now it's on the operation side. So once I do have this deployed, now I have to manage it. Now I have to troubleshoot it. So let's make sure we have the right tools to do that. And then there's pay as you grow. So pay as you grow is available on the 9540 and the 9640. You can see from the graphics there. With the 9540, you can actually purchase the switch as a 24 port switch, 24 ports of 10 gig, 24 ports 1 gig. The 100 gig ports don't have to be enabled. So the beauty here is that the switch comes with 24 ports of 10 gig enabled. We have 24 ports of 1 gig enabled. If I decide I need more of the 10 gig ports, I add a license. If I decide I want to enable some of the 100 gig ports, we add a license. And the beauty of this is that the license can be applied while the router is running. Doesn't require any kind of a reboot. I simply apply the license and the ports are now available for use. With the 9640, we basically will ship the router in two forms. One is with 24 ports of 1/10 gig and 4 ports enabled of the 100 gig. And then you can enable 4 ports and 4 ports again with the port on demand licensing there. So what we're trying to do here is make things as cost effective as possible. Understanding that, maybe having 48 ports of 10 gig is just way too much. I don't need it. I won't need it. We all know you never say never. So the beauty here is that we can install a switch. You can use the ports as shown. And then as you need to grow, you don't have to replace the hardware. You don't have to rip things out. Those ports are there. They're just kind of sitting there dormant. And when I decide that it's time, I need to move from 10 gig to 100 gig for my uplinks or various connectivity, I can enable those 100 gig ports. But I don't have to pay for those 100 gig ports day one. So I may not need that for 6 months, 12 months, 24 months, however long. But the beauty here is that it's there. The box is there. I don't have to do any kind of changes to the hardware or any of the physical connectivity. So we really want to create a frictionless experience to you be able to increase the capacity as you need it and when you need it. All right, so in summary, if we look at the things that are bolded in red, exceptional performance, network security, pay when you need it, and that guest VM. I think if we look across, the solution set, you have the flexibility of the different port configurations, the different types of routers, the different route scales, where things all fit. The security is ubiquitous across all of these platforms. Giving you some flexibility on the lower end platforms for the pay as you grow, and then the guest VM being available on all of these boxes. Just a really good way to help with the overall management, the analytics, the troubleshooting, and things of that nature. So again, this is a long heritage, very mature technologies that we continue to harden and expand. Starting from those days of Foundry networks and into Brocade and now into Extreme. We're very excited about the capabilities of what we have here. And as I say, we'll continue to add more features, more capabilities to further enhance those solutions. And that'll come across all different areas, whether it be additional security features, additional scaling features, additional routing type capabilities, all of those things, all into this very powerful routing platforms. So with that, I'll conclude the presentation. I hope this was time well spent and very helpful for you. I do appreciate you tuning in, and thank you very much. Have a good day.